Namaskar. The topic of discussion in this module is on fluvial landforms. The hydrological cycle is an everlasting process on earth. In this process, rainfall is the basic input coming into the surface. Flowing surface water is the result of total precipitation minus evapotranspiration and infiltration into the ground. The water flowing as a stream performs three kinds of geologic work as erosion, transportation and deposition. Hence, the running water is considered as one of the geological agents on earth. The word fluvius in Latin refers to river. The word fluvial is used to denote running water as a stream or river. The flow of water has a force, it has a velocity, it also has the power to generate power. There are many natural and dynamic processes happening along a river. Sometimes there may be severe floods along the river courses which can destroy everything along the flow path. Natural hazards are also caused by these streams. Flowing water has the ability to dissolve many soluble mineral substances along their way. Rivers and running water are considered to be dynamic geomorphic agents. Fluvial processes entail the erosion, transportation and deposition of earth's materials on the surface of the earth. The fluvial processes and fluvial landforms dominate the land surface all over the world. Understanding of the fluvial geomorphic process is an essential aspect in physical geography. Hence, the following aspects are highlighted in this section: streams and drainages, erosional work of streams, transportation by streams, erosional landforms and depositional landforms. Let us see the first part of streams and drainages. Streams are flowing water bodies. The flow of water starts after every rain. Rainwater also falls on all slopes of a land, gets collected and start flowing as overland flow. The flowing water merge along the converging slopes, join together and run as main streams. The main stream normally contain the cumulative volume of flow. The total water flows out of a single outlet is called as river mouth. The entire area encompassing the catchment zone up to the river mouth controlling this cumulative flow is known as a river basin. A river basin is the hydrological catchment zone of a river. It is also called as a drainage basin. It is a single major hydrological unit comprising all inputs from rainfall and all outputs as infiltration, surface runoff and river flow towards the sea or any other major confluencing point. A portion of the water that enters into the groundwater system beneath the drainage basin may also flow towards the outlet. The measurement of the river flow, which is also called as discharge of water from a basin, may be made by a stream gauge located at the basin's outlet. A drainage basin is an important hydrological unit considered in fluvial geomorphology. A drainage basin is the source of water and sediment that moves through the river system and reshapes the channel. Streams develop due to the erosive power of water. Slope of the land, nature of the rock type, structure of the rocks, extent of weathering and mass wasting processes on the land, climate and frequency of rainfall, all are responsible for the creation of a stream or they are responsible for stream development. Streams are classified based on their growth and development. Stream order is a method for classifying the relative location of a reach within the large river system. An ordering method proposed by Hutton in 1945 is the simple method for understanding the stream ordering methodology. Stream ordering technique assigns each headwater perennial stream an order of 1, and then at the confluence of two first order streams assigns the downstream reach an order of 2. In this method, the confluence of two second order streams results in a downstream side as third order stream, and so on. In a bigger river basin, the total streams may include several thousand first order streams, hundreds of second order streams, tens of third order streams, a dozen of fourth order and fifth order streams, and a few sixth or seventh order streams. Finally, the stream may end in 8th or 9th order when it reaches the confluencing point. Every stream has its own valleys. Valleys are common on the earth's surface. A valley is a depression on the earth's surface drained by water under the attractive force of gravity and exists between two adjacent uplands. Every valley has its own length and slope. The horizontal distance measured in the cross section in a linear depression between two adjacent upland is known as its length. The slope of a valley for a given reach refers to the difference in elevation between the upstream end to a point of reach along the downstream end. Valley development is a unique hydraulic process. It happens due to three concomitant processes as valley deepening, valley widening, and valley lengthening. Valley deepening is affected by hydraulic action, corrosion and abrasion of the floor of the valley, pothole drilling along the valley floor and at the base of the waterfalls, corrosion and weathering of the stream bed. Valley widening is accomplished by lateral erosion or planation by the stream in a valley, hydraulic action, corrosion, rain wash and sheet wash, gullying on valley sides, weathering and moss fasting, and the role of incoming tributaries. Valley lengthening may take place due to three ways as extension by headward erosion, increase in the size of their meanders, and extension at the confluence due to subsidence. The maximum downward limit for valley deepening is known as the base level of erosion. In some cases, the channel length may increase due to a meandering course of a river, but the valley length is short. A river is said to be starting from an youthful stage, runs through a mature stage, and reaches its old stage depending upon its age, length of flow path, density of streams, population of its streams, discharge volumes, and width of its mouth. All these factors contribute to the age of a river. A youthful stream is one that is undergoing initial development. Consequently, it has a steep irregular gradient, few tributaries or meanders, and a narrow floodplain. In addition, most of the erosion takes place in a downward direction. Next comes the mature stage. As time progresses and erosion continues, the stream gradient decreases. The number of coarse deflections on the other hand increases, so that the stream gets more meanders. Eventually, the degree of lateral erosion becomes equivalent to that of the downward erosion. This intermediate stage of development is referred to as maturity stage. The third stage is the old stage. The final stage of stream evolution occurs when lateral erosion takes precedence over undercutting or downcutting. These so called old age streams have very low gradient and wide floodplains. Every stream has its longitudinal profile and lateral cross sections. The longitudinal profile of a stream is analyzed to know the water surface slope. It helps to compute the velocity of flow and also understand the gradient. The transverse profile helps in identifying the nature of topographic floodplain and hydraulic floodplains. The actual water flowing zone in a river is called as the bankfull elevation.